Erosion by running water. As you listen to these notes and move from slide to slide, record the writing that you see in red on your own handout. When you're done, go and complete the erosion by running water question sheet. Weathering of rock produces particles that are moved by the process of erosion. Erosion is the transportation of rock particles from one location to another. Over time, erosion shapes and lowers the Earth's surface. Sediments displaced from their source are evidence of such erosion. Sediments can be seen in muddy rivers, on beaches, in rock fields near glaciers, along riverbanks, and in soils. Running water is the most common agent of erosion on Earth's surface. Water that does not soak into the ground or evaporate into the air flows across the ground and is called runoff. Erosion begins when runoff carries small particles of soil downhill. Runoff gradually forms small channels in the soil, which eventually join together to form larger ones. Larger channels then flow together to form streams and rivers. Sediments can be transported by a stream in many different ways. The amount of sediment carried in a stream is called the stream load. Dissolved minerals that are carried in the stream are said to be in solution. Some examples of dissolved minerals could be calcite and halite, or just salt. Sediments that are not dissolved in the river or carried along its surface are said to be in suspension. Sediments of small size, such as clay, are suspended very easily. They are small enough that the moving water keeps them afloat. Larger sediments are moved by rolling and sliding or bouncing along the stream bed. We call this the bed load. The picture on the bottom left shows the suspended load, where particles of clay and sometimes silt are floating right in the middle of the river. Saltation, or the bouncing, on the right-hand side picture, shows that some particles can bounce and repeatedly hit the bed of the river as they move downstream. This slide shows a picture of rocks that have been abraded. They look round, smooth, and smaller than they once were. As rocks bump into each other as the water moves them downstream, they become like these rocks you see here. One of the most important concepts that you need to understand about river erosion is that rivers form V-shaped valleys. Over time, streams and rivers carve deep channels. The V-shaped valley results from the combined actions of stream downcutting, runoff, and mass movement, or the erosion caused by gravity, which causes the sides of the valley to cave in. This characteristic V shape is what you need to remember for the Earth Science Regents exam. At the very end of a stream or a river, there's often a fan-shaped delta. Streams carry and deposit billions of tons of sediment as they flow towards the ocean. Over time, the delta builds up, forming a triangular shape. As water slows down when it enters a larger body from the stream, it deposits the sediment it cannot carry any longer. This is a characteristic shape that can be seen around the world, like the Nile River Delta to the right in a picture on this slide, and in Louisiana, the Mississippi River Delta. Three factors are important in determining the velocity of a stream or a river. One factor is the gradient or the slope of the stream. Another factor is the discharge or the volume of water in the stream. An increase in either stream discharge or stream slope leads to an increase in stream velocity. The greater the velocity of the stream, the larger the sediment particles it can carry. The third factor involved in stream velocity is its channel shape. The figure below shows how stream channel shape affects stream velocity. Notice that a wide flat stream channel on the left side has a larger surface area in contact with moving water. This increases the friction between the water and the stream bed and slows down the stream. In contrast, a semicircular stream channel shape shown on the right side has less friction with the water and the ground, allowing the stream to have a higher velocity or speed. Water does not move at equal speeds in a stream or river. In a straight portion of the stream, the maximum velocity or speed is in the center, near the surface. This is because at the surface and at the stream bed, the velocity is reduced by friction. When a river channel curves, the water will flow the fastest on the outside of the curve. Any curve or turn in a river is called a meander. The faster the flow, the more erosion will take place. On the outside of a meander, erosion takes place because the water is moving quicker and able to transport sediments away. On the inside of a meander, sediments are deposited because the water is moving more slowly and dropping them. Looking at the profile to the bottom left, you'll see what a stream looks like from the side as erosion and deposition are taking place.